Assalamualaikum and very good morning. My name is Muhammad Farid bin Fauzi, metric number AD150158 from section 4. Today I would like to present my project which is the subject BDA24202 computer program. Now we move to the next slide, which is introduction for this project. The introduction is to introduce that what we have done in the subject. For example, we have apply what we have learned from our lecturer to this project. And the second is for this subject we have been given the project for so the task for this subject is to write the C program to solve the problem that related to fluid mechanics. Okay, and now we move to the problem statement. The problem statement for this subject, this project is write a C program that calculate the kinematic viscosity and Reynolds numbers for a pipe having diameter 0.1 meter, average speed 0.1 meter per second, and the dynamic viscosity and density are given in the table. And this is the formula for the kinematic viscosity, which is dynamic viscosity over density, and for the Reynolds number is velocity times diameter over. Okay, and now we move to the objective. The objective is to know how to construct the flowchart and write the C program without any errors. And the second, able to use the C language and know how to apply the C language for the engineering problem. And the third is able to identify a program with any errors from different loops. And for the fourth is able to use the C program to solve the problem that related to the engineering problem and mathematics problem. And this is my flowchart that related to the problem. So from this flowchart we can see that it has 4 loops and 2 functions. Okay, and this is the part of the flowchart. For this flowchart is regarding to the type 1. The type 1 we know it as water. Okay, so for the water, from the decision we know that our density is 1000 and U is the viscosity. And now we move to the decision, and from the decision we define that U viscosity kinematic K from the formula, and we define it K equal to U over S. And now we move to the another process table, which is we define it the diameter equal to 0.1, V equal to 0.09. And now we move to the next decision table. For the decision table we define it the V less than or equal to 0.09, and then we define the formula of Reynolds number, which is V times D over K. And for the display we explain about the meaning of symbol. So next we move to the another decision table. This we state it as Reynolds number less than or equal to 100, and this is the type of fluid is laminar flow. And then we move to the next decision table, which is Reynolds number bigger than or equal for 4,000, which is the turbulent flow. And if the value is not regarding to this value, so we state it as unstable flow, and then it moves to the increment. So the v equal to v plus 0.01. So from this from this after that the v will repeat the same step after it get the value v equal bigger than 0.09. So the program will go to the end. Okay. Okay, and now we move to the second loop. The second loop is we define it as type 2. The type 2 is the fuel oil. So it run the program same with the previous loop. Okay, this is the third loop. The third loop we define it as gas oil. The gas oil we define it as type 3, and it also run the same method. Okay, and this is the type 4. The type 4 is we define as the kerosene. The kerosene from this project, we also use the same method to run and to know the type of this flow. And after that, this is the final flow from the flow chart, which is the end. And now we move to the C program. And the C program is, for the first is we define its float B, float RE, float D, float V, and float K. And now this is the integer type. The float is the integer type is float viscosity, density, X, U, V, D, R, E, and K. And now we print it to we print as enter the type of fluid. Print F, we state the type of the fluid, and then we print F, we please enter the D to define the diameter. And for the print F, we write the please enter X to define the value of density. And this is the loops for the type. And this we define it the type 1, and we state it as if. The if we follow from the flowchart, and we state the print F, the type fluid of water, U equal to 1.00 times power bracket 10 negative 3. And for the flowchart, we got that we use the 4 loops. So we state it from to programming. V equal to 0.01, V less than or equal 0.09, and V plus 0.01. And this is we state the formula. K equal to U over X, and RE equal to V times D over K, and we state that B bracket RED V K. So we print F, the end of the water fluid type. So after that, we state another types. We state as else if. So the loop will run the same method with the type 1 and also the third and also and the fourth. So after that we state another function to determine the value of RE. So to determine the value of RE, we state that float B bracket float RE float D float V float K, and we print F the pipe diameter is something, and print F the velocity, and print F the kinematic viscosity, and the print F Reynolds number. So we also state that if RE less than 2100, the type of the flow is laminar, and also we state that RE bigger than 4100, the type flow of this value is turbulent. So we also state that the type flow of the unstable flow. So this is the program of the problem regarding the problem. So we move to the next slide is the result. So the result we get the for the fluid water is Reynolds number 1000, and the type flow is turbulent flow. And this the result for the fuel oil, we get the Reynolds number is 2775.52, and the type of flow is unstable flow. And the type and the third is the value for the gas oil, the Reynolds number is 15,000, and the type of flow is turbulent flow. And this is the lastly we get for the kerosene is 4187.50, and the type of flow is turbulent flow. And for the conclusion is I can conclude that I able to construct a flow chart and write the C language based on the flow chart. And although and also at the first time I have faced many problems to write the C program, but I already overcome the problem of the error by refer the note that has been given. The net is I also able to identify the error in the loops. So in other hand, I am able to write the C program and understand it based on what I have learned in the class. So the lastly, I am able to apply all the knowledge within the computer programming on fluid mechanics to solve the engineering problem. So that's all for my presentation. Thank you.